We now solve this initial value problem. So here we have the equation y double prime minus 3y prime plus 2y equals 3 times cosine 3t, and the initial conditions are given as y of 0 equals 12. I'm sorry, it is 2, and y prime of 0 equals 3. So we are going to find its solution by the method of undetermined coefficients. And this basically involves four steps. The first step, we find the homogeneous solution. And in the second step, we find the particular solution. And in the third step, we find the general solution of the given differential equation. And finally, we solve for y by plugging in the initial value conditions. So let's start off with the step 1. So here we have to determine the homogeneous solution. For this, I'm going to write down the characteristic equation. That is, we have to take the second. I'm sorry, the expression on the left. That is y double prime minus 3y prime plus 2y, and this equals 0. So this is the homogeneous equation. Let's write the characteristic equation. I'm going to replace y double prime by r squared and y prime by r, so it becomes 3r, plus y is replaced as 1, so 2 times 1 is 2. So this is our characteristic equation. Let's solve this. This is a quadratic equation. We can factorize this. That is r minus 2 times r plus 1. This equals 0, because the product, that is negative 2 positive 1, the product gives negative 2. I'm sorry. So this 1 should be negative 1. It is not positive 1. This should also be negative. So I put negative here. So negative times negative 1 is positive 2, and negative 2 plus negative 1, and this equals negative 3. So this is the negative 3, and this positive 2 is the product of two numbers. So this factorization is correct. Let's continue. And this implies r minus 2 equals 0, or r minus 1 equals 0. So we get two values for r. We can say r1 equals 2 and r2 equals 1. So we found the values of two r's, and this means we can write down the homogeneous solution. That is yh equals, I'm going to use one constant, that is c1 e raised to the power of r1t plus c2 e raised to the power of r2t. So let's replace the r1 and r2. So therefore yh equals c1 e raised to the power of r1 is positive 2, so it becomes 2t, plus c2 is another constant, times e raised to the power of r2 is 1. So 1 times of t is t. I'm going to put only t over here. So this is basically the homogeneous solution for the given differential equation. This completes step 1. Let's do step 2. That is, we have to find the particular solution. So to find the particular solution, we have to look at this given differential equation. That is particularly the right side of this differential equation. Here we have 3 times of cosine of 3t. So I'm going to write down this particular solution, and this could be in the form of a cosine of 3t plus b cosine of, I'm sorry, b sine of 3t. So we write this particular solution since the right side expression is a cosine 3t. And now, since the differential equation involves a first derivative as well as the second derivative, we also find the first derivative of this particular equation as well as the second derivative. First, let's find the first derivative of this particular solution. So this is yp prime, and this equals, we have to find the derivative of a cosine 3t. So we put a constant. Derivative of cosine 3t is negative sine 3t. We have to apply the chain rule here. So first I found the derivative of cosine function, which is a negative sine function. So I put this as negative sine 3t, and then the derivative of 3t by applying the chain rule, and this equals 3. So I put this 3 here. So we are done with the first term, that is the derivative of the first term. Now I put this b, and then find the derivative of sine 3t. So here also we have to apply the chain rule. Derivative of sine function is cosine function. So I put cosine of the inner part, which is 3t, and then once again we have to apply the chain rule to find the derivative of 3t, which is 3. So we put 3 here. Let's get this simplified. So we get yp prime, and this equals, this is 3, and we have negative, and we have a. So the product of these three will be negative 3a times of sine of 3t, and plus, so we have b times 3 is 3b. So I write this as 3b cosine of 3t. Now let's find the second derivative of this. So we find the derivative of the yp prime, and this is yp double prime, and this equals, we find the derivative of this expression. So we have a constant negative 3a, we put a negative 3a, and from the previous derivative we know that derivative of sine 3t is, we can put this as 3 times of cosine of 3t. After we apply the chain rule, we'll get this expression. And now let's do for the second term. So I put this 3b, and once again the derivative of cosine of 3t, according to the chain rule, this will be negative 3 sine of 3t. So let's simplify this. So this gives yp double prime, and this equals, we have a 3 and 3a, negative 3a, so this becomes negative 9a cosine of 3t. Then we have 3b times negative 3 is negative 9b sine of 3t. Now to determine the values of a, b and c, we take this yp as well as this yp double prime, and also the the yp prime we have here, as well as the yp double prime. We plug it into the original equation, that is this original equation. So first let me copy the original equation, that is we have y double prime minus 3y prime plus 2y, and this equals 3 cosine 3t. So 3 cosine 3t. Since I'm going to substitute the yp's, I can rewrite this as yp double prime plus 3y prime plus 2yp. So I'm going to substitute the yp double prime, y prime, and yp into this equation and solve for the constants a, b, and c. So first, let me substitute the yp double prime. The yp double prime is negative 9a cosine 3t minus 9b sine of 3t. So then I have to find this negative 3yp prime. So I put negative 3 times of yp prime. Let me replace the yp prime, which is negative 3a sine of 3t. So I put negative 3a sine of 3t plus 3b cosine of 3t, 3b cosine of 3t. And then I have to replace the yp, that is plus 2 times of yp. Yp is a cosine 3t plus b sine 3t. So I replace it here. So we have a cosine 3t plus b sine 3t, and on the right side we have 3 times of cosine of 3t. So basically we have to simplify this, equate the coefficients of cosine 3t and sine 3t and solve for a. So let's do this. So we have the first two terms remains the same. So I write out negative 9a cosine of 3t minus negative 9b sine of 3t. Let's distribute the negative 3 inside the two terms. So negative 3 times of negative 3a, this is positive 9a sine of 3t, and then negative 3 times positive 3b. This is negative 9b cosine of 3t, plus 2 times of a is 2a cosine of 3t, plus 2 times of b is 2b sine of 3t. You can put bracket for this, and this equals, on the right side we have 3 times of cosine of 3t. Now I'm going to factorize the cosine of 3t as well as the sine of 3t. So let me factor the cosine of 3t. So we have negative 9a. This is one cosine of 3t, and negative 9b. This is another cosine of 3t, and we have one more, that is positive 2a cosine of 3t, plus, now let me factor the sine of 3t, and when I do that, this is negative 9b, so I put negative 9b. This is another sine 3t, which is positive 9a, and then we have one more sine 3t, which is positive 2b sine of 3t. So this equals, on the right side we have negative 3 cosine 3t. We now simplify these expressions, that is negative 9a, we have negative 9a and positive 2a. So this is basically negative 7a, and then we have negative 9b. And this one is negative 9b plus 2b. So this is negative 7b plus 9a. I'm going to replace it here. So I just remove this. Okay, so here I have simplified the terms inside the brackets, and now we can equate the coefficients of cosine of 3t and sine of 3t. Uh, if we look at this left side expression, we have cosine of 3t, and here also we have the cosine of 3t. So therefore, the factor of cosine of 3t, or the multiplier, is negative 7a, negative 9b, and this must equals negative 3. So we write down the equation, negative 7a, negative 9b, and this equals negative 3. This is one equation. We have a sine 3t term here, but we don't have sine 3t term. So I can simply put this as 0 times of sine 3t. And this means the coefficient of sine 3t is positive 9a minus 7b. This must equals 0. So now we have a system of two equations in a and b. We can solve it by substitution or elimination method. So let me utilize elimination method. In this method, I have to make one of the variables as same in both equation. So I'm going to, let's say this is equation 1, this is equation 2. I multiply the first equation by 9. So I take the first equation, multiply by 9, and I take the second equation, multiply by 7. So this is 9 times of negative 7 is negative 63a. Then 9 times of negative 9 is negative 81b. And this equals 9 times of negative 3 is negative 27. Now multiply the second equation by 7. So 9 times of 7 is 63. So it is 63a. 7 times negative 7 is negative 49p. And this equals 7 times 0 is 0. So now we have to add these two equations. So negative 63a, positive 63a, they will get cancelled. And then we have negative 81b, negative 49. This is 81 plus 49. This equals 130. So it is basically negative 130b, and this equals negative 27. I just observed that this has to be positive 27. In fact, this negative 3, this has to be positive 3. Let's go back to our original question, because we know that it is positive 3 cosine 3t. It is not negative 3. So I have to replace this starting from here. This is not negative, it is positive. So this will also be positive 3. This will be positive 27. So I have just corrected this. So this implies we solve for b, and this equals 27 over negative 130. So this is can be written as negative of 27 over 130. So we found the value of b equals negative 27 over 130. Now let's solve for a by plugging it into either equation 1 or equation 2. I'm going to plug it into the equation 2. Looks like it is simpler. So we get 9a minus 7b equals 0. So 9a minus 7b equals 0. And this implies if we add 7a to both sides, we get 9a equals 7b. So a equals 7 by 9 times of b. So we just have to substitute to b. Therefore, a equals 7 by 9 times of b. b is negative 27 over 130. So this is negative 27 over 130. This 27 goes into 9 as 3 times. We have a negative, so it is negative 3. And 7 times negative 3 is negative 21. So therefore, we say that a equals, the numerator is negative 21 divided by the denominator is 130. So we found the value of a equals negative 21 over 130. And this means we can now write down the particular solution by substituting into the equation for yp. So let's do that. So we will get a particular solution, that is yp equals a times of cosine of 3t. So it is negative 21 over 130 cosine of 3t plus b times of sine of 3t. b is negative 27. So I put negative 27 over 130 sine of 3t. So this is the particular solution for the given differential equation. This completes step 2. Let's do step 3. So here we have to determine the general solution. So basically we have to add the homogeneous solution and the particular solution. So therefore we see that yg, which is the general solution to the given differential equation, and this equals a homogeneous solution, that is c1 e raised to the power of 2t plus c2 e raised to the power of t plus the particular solution. Since both the particular solution terms are negative, I'm going to replace this as negative. So this is negative 21 over 130 cosine of 3t, then negative 27 over 130 sine of 3t. You can just move this here. Let me see. Okay. So this is basically the general solution to the given differential equation. And this completes step 3. Let's do step 4. So here we have to find the unique solution, that is the actual solution of the differential equation. For this, we have to use the initial condition, that is y0 equals 2 and y prime of 0 equals 3. So first, let's determine the y of 0. So y of 0, we replace t by 0 into the general solution. So therefore, we get y of 0. We can replace this as y of 0, and this equals c1 e raised to the power of 2t. So 2 times of 0 is 0, so it becomes e power 0, and this in fact is 1, so I'm just going to put only 1 here, plus c2 e raised to the power of 0 is once again 1, so I just put c2 minus 21 by 130 cosine of 3t, that is cosine of 3 times of 0. So it becomes cosine of 0, and this equals 1. So I can put 1 here, minus 27 by 130 sine of 3t. So sine of 3t, that is sine of 3 times of 0, and this equals sine 0, which is 0. So this is negative 27 over 130 times 0, which means it is 0. So I can simply just ignore this, and this multiplier I just put this as just negative 21 over 130, and this is given as y of 0 is given as 2, so we can write down this as 2. That is, let's simplify as c1 plus c2, and this equals, we add 21 by 130 to both sides, so therefore this becomes 2 plus 21 over 130, and this equals, we can simplify this, so we get c1 plus c2. We have to multiply this 2 with 130 and divide by 130 to get common denominator. So 2 times 130 is 260. So I can write this as 260 divided by 130 plus 21 over 130, and this equals 260 plus 21, and this gives 281. So it is 281 over 130. So let's write down this as an equation, that is C1 plus C2, and this gives 281 over 130. This is one of our equation. Now to utilize the second initial condition, we have to find the derivative of this general solution, and then plug in t equal to 0 and solve for C1 and C2. So first let's find the derivative of this general solution. I write down this as y prime, and this equals the derivative of c1 e raised to the power of 2t is, we will put c1 as the constant, and derivative of e raised to the power of 2t, when we use the chain rule, we get 2e raised to the power of 2t plus c2, derivative of e power t is e power t, and then we have negative 21. This is negative 21 over 130 times of derivative of cosine 3t. When it is the chain rule, we will get negative 3 times sine of 3t. I close this. Now I find the derivative of the last term, that is, we have the constant negative 27 over 130 times the derivative of sine of 3t is 3 cosine 3t. Now let's replace t by 0, and y prime of 0 equals 3. So here on the side we get y prime of 0. We have to replace all t's by 0. So therefore this will become c1 times 2, that is 2c1. E power 0 is 1. So you can just put this as 2c1, and plus e power 0 is 1, so it is c2, and wherever we have a sine function, when we replace t by 0, this will become 0, so I can just ignore this complete term, and wherever we have cosine function with t, if we replace this 3t by 0, that is t by 0, this becomes cosine of 0, which is 1, so we just have this multiplier negative 3. So I can write down this as negative 127 by 130 times 3. Let's multiply this 27 times 3, and this equals 81. So I can just replace this as negative 81 by 130. And this is given as, that is, y prime of 0 is given as 3. So we equal this as 3. Now we write the equation in terms of C1 and C2. So we have C1, 2C1 plus C2. We add 81 by 130 to both sides. So we get 3 plus 81 by 130. Now I multiply this 3 by 130 to make a common denominator. So 3 times 130 is 390. This is over 130. So it's basically this is 390 over 130 plus 81 over 130. So we now add 81 and this gives 211. So this is 211 over 130. So we have the equation 2c1 plus c2. This equals 211 over 130. This is second equation which we will utilize to solve for c1 and c2. Okay, so here we have two equations. I also observe that this should, I'm sorry for that, this should be 471 by 130. This has to be 471 over 130. So we have these two equations in variables c1 and c2, which is a system of equations in two variables c1 and c2. When we solve this, we get c1 equals 19 by 13. You can solve this using the substitution or elimination method. So upon solving this, we are getting these values, and c2 equals 7 over 10. So all that we do is we plug in these values into the general solution to find the final solution, that is the unique solution. So we write down y equals c1 is replaced as 19 over 13. This is e raised to the power of 2t, plus c2 is replaced as 7 over 10 e raised to the power of t, minus, and we then write the next two terms, that is 21 over 130 cosine of 3t, minus 27 over 130 sine of 3t. So this is the final solution to the given differential equation.